Hi everyone, welcome back to our channel. Today we are going to find the theoretical calculation for the given T network and we are going to find the Z parameters for the given T network. Let's try to see the procedure. So this is very important. So we will do the theoretical calculations for this T network and we will validate with respect to an hardware also. So the first step we will do the theoretical calculation and second step will be followed with the practical experimentation. Okay, now coming to the theoretical calculation. So this is the given T network. Now let's try to see how to write down. So the basic equation we have in our hand is V1 is equal to Z11 I1 plus Z12 I2, and second equation is V2 is equal to Z21 I1 plus Z22 I2. So in order to find all these four parameters, initially how to make this parameter as 0. So that's why I am making I2 is equal to 0. When I make I2 equal to 0, then this you can see here, this I2 value is 0, then Z11 value is equal to V1 by I1 is the first step you have to find out. Next, Z21. So how to find Z21? Z21 is equal to V2 by I1 is the second step. So in the next step what I have to make is this parameter you have to make as 0. Therefore I am going to make I1 is equal to 0. Whenever I1 is 0, automatically the value of Z12 is equal to V1 by I2, and the value of Z22 is equal to V2 divided by I2. So these are the four parameters we need to find out for the given T network. Okay, so let's try to see here. Generally we can directly do it by one step, so let us try to validate in later. So without solving I can say Z11 is nothing but the sum of series branch and shunt branch. So this will be 820 ohms plus 510 ohms, and Z12 is equal to the shunt branch. This is the shunt branch. So shunt branch we are going to get it as 510 ohm, and next one is Z21. Z21 is also the shunt branch, which is nothing but 510 ohm, and next value is Z22. So Z22 is the sum of output port resistance and shunt branch, which is nothing but 2000 plus 510. So this will be the values we will be getting by solving as per the procedure. So this I am going to call it as an indirect method or the shortcut method of finding Z11. So we will use the conventional method how to do experimentally also. Now let's try to do it by direct method of solving. In this direct method we are going to get is, so in this direct method we are going to make I2 is equal to 0. You make I2 is equal to 0, then we are going to get Z11 is equal to V1 by I1 as well as Z21 is equal to V2 by I1. Okay, so this what you have to get. So here it is saying that we have to make the output current as 0. Okay, let's try to see here how to make the output current as 0. So the network will be resolved into like this. Okay, so we are going to have a 30 volt source here, and you are going to have 820 ohm, and you are going to have a 510 ohm, and here this 2 ohm resistor, this is open. Okay, so open, and this is the source is available. So whenever it is open, the voltage cannot be applied here. Here the current I2 is equal to 0. So current into resistance, what is this value of resistance is 2000 ohms. Okay, 0 into 2000, where the voltage V is equal to voltage V equal to I into R. I is how much? 0. R is how much? 2000. So 0 into 2000 is once again 0. Therefore this completely branch will act like an short circuit. So I'm going to redraw it after performing the I2 equal to 0. Then you are going to get one branch here, then you are going to get another branch here, then this is the value of V2 we are not applying. Okay, so since it is shorted, this node will be shifted to this point. Okay, so this node will be shifted to here, and here we are going to get V2, and here we are going to get 0, and the value of this resistor is 510 ohm, and the value of this resistor is 820 ohm, and we are applying an voltage of 30 volts. Okay, here you can see here what we need to do is, what we are applying is V1. Okay, so V1 is how much? So we need to find out. V1 is already given in the data, V1 is already given, and we need to find out the value of I1, and we need to find the value of V2, and we need to find the value of I1. Okay, so we need to find the two quantities. The first quantity is V2 value, and the next quantity is I2 value. These two quantities we need to find out. So how to find? Now let us try to discuss. Okay, so how to find this V2 is, okay, so this V2 I have to find out. So this is like nothing but the voltage across 510 ohm. Okay, so voltage V2, which is nothing but the voltage across 510 ohm, I'm going to use voltage division rule. By using voltage division rule, voltage at 510 ohm, which is nothing but total voltage. What is the total voltage we are having? 30 volts into where we require the voltage is 510. Write down the given resistance 510 divided by the sum of resistors which are connected in series. 820 and 510 both are connected in series. Why? Because the current is not flowing in this branch. Okay, so and this is already, there is no resistor and it is shorted, and this is the voltage V2 by the sum of resistors which are connected in series, therefore which is nothing but 820 plus 510. Just use the calculator and you are going to get the value of V2. Okay, so when you do it like this, you are going to get the value of V2 with the help of calculator as 11 volts. So the voltage here you are going to get it as 11 volts. Okay, so when you get this 11, automatically I2 is completed. So now we need to get the value of I1. Okay, so very simple to get I1. So this is the source, and this is 820 ohm, and this is nothing but 510 ohm. So this is 510 ohm, this is 820, and after solving the value of V2, we obtained it as 11 volts. So here it is 11 volts of positive terminal and negative terminal of 0 volts, and here it is of 30 volts, and here it is of 0 volts. So we need to find out the current I1. Okay, so now let's try to mark this current as some I1. Generally this will flow in this direction. Okay, so let's try to change it after doing the calculation. So how to find the value of I1? So I1 is equal to, the formula is V by R. So what is the voltage we are here having? So voltage, I mean V by R. Okay, how to write down the voltage? Current is leaving. What is the leaving polarity of the voltage? 11. What is the next leaving terminal is minus 11 minus 30 divided by R. What is the R value? Which is nothing but 820. Okay, so just do with your help of calculator, then you are going to get as, since it is negative terminal, minus 23 milliamperes is the current. Okay, so the current is flowing like this, and this magnitude is minus 23 milliamperes. If the current I1 is flowing in this direction, this will be just reverse, which is nothing but plus 23 milliamperes. So successfully we find the two values to what we actually require. Okay, so now let's try to find out these values. First one is Z11 is equal to V1 by I1. Okay, so what is the value of V1? Already it is there, 30 divided by I1. I1 is how much? So when you take in this direction, original direction, which is nothing but 23 milliamperes. And next one we are going to find out, which is nothing but Z21. Okay, so Z21 is equal to V2 by I1. Okay, so what is the value of V2? So already we had solved. The value of V2 is how much? 11 divided by I1. I1 is 23 milliamperes. Use your calculator, then you can find out the value of Z11 is 1.3, and this 10 to the power minus 3 will come to numerator, which is 1.3 kilo ohm, and this we can get it as 0.478 kilo ohms. Here also you can see here 478 are approximately 500. Here also 510 ohms. Okay, almost all the answer is same. Okay, so you may ask why there is a little bit change. So this is nothing but we have in milli and we are considering only 2 decibels. That's why the value decreased. If you take 4 to 5 decibel, then you will get the same. So this is also, if you add 820 plus 510, approximately here also you are going to get 1300 ohms. You write down in kilo ohms, which is nothing but 1.3 kilo ohm. So when you do by direct method or indirect method, the answer is same. Okay, now let us try to do the second step. In second step, what you have to do is you have to make I1 equal to 0. Okay, so this we need to perform. So this step we need to perform. Okay, so let's try to redraw the network. Same procedure, we are going to redraw the network. So here also again the second step we are going to proceed like this. Take I1 is equal to 0. When I1 is equal to 0, then we need to find out the parameters. Z12 is equal to V1 by I2, and next parameter is Z22 is equal to V2 by I2. Okay, so now let's try to redraw the network. So when you redraw this same network, let's try to copy it. See here, this is the network given, and here you have to make as I1 is equal to 0. So when I1 is 0 here, okay, I'm going to redraw it for your clarification. So this is the source, and here I1 is 0. Okay, and we have the same resistor 820 510 like this, and here we have the 2000 ohm continued with 30 volt source. So this is an 30 volt source at this point, which is nothing but 30 volt source, and this is an 0 volt source, and here you are going to have 2000 ohm, and here you are going to have 510 ohm, and this is now open circuited. Automatically I1 is 0. Whenever I1 is 0 and it is having a series connection of 820, so the total voltage, if you find out, V is equal to 0 into 820, which is nothing but 0 volts. Okay, so when you do it, then automatically here voltage is 0 means this branch will act like an short circuit, and since current is 0, there's no need to apply the source. So this V1 will be shifted to this point, and here you are going to get V1. I'm going to redraw the network again, which is nothing but the voltage at this point is V1, and the resistance at this point is 2000, continued with a 30 volts source. This is a 30 volt source, and this is a 2000 ohm resistor, and this is a 510 ohm resistor, and this voltage, which is nothing but V2. Okay, so what are the parameters here we need to find out is already V2 is how much? 30 volts. Okay, V1 we need to find out. Okay, so the unknown we need to find out is V1 we need to find out, as well as we need to find out the value of I2 value also we need to find out. See here, so here I have to find out V1. So how to find the voltage V1? I want the voltage across 510. So voltage V1 across 510 ohm is equal to, what is the total voltage we are applying is 30 volts into where we require the voltage is across 510 into 510 divided by the sum of resistors which are connected in series. You can see here these two resistors are connected in series, which is nothing but 2510 ohms. This is also 510 ohm. Automatically the resultant, after doing with the calculator, you are going to get it as 6 volts. Okay, So now V1 here we have been obtained as 6 volts. So V1 is equal to 6 volts. First task is completed. Next we need to find out the value of I2. So how the current I2 will flow? So in this direction only the I2 will be flowing. Okay. So I2 is flowing like this. How to write down the current I2? So current I2 is equal to, so how to write down this current I2? Current I equal to V by R. Okay. So what is the voltage at this point is 30 volts. The current is leaving. What is the voltage we have? Plus 30 volts minus, here the potential is how much? High potential minus low potential divided by R. R means the current is I2 is flowing like this. I can say these two are connected in series, which is 2510 ohm. Then you are going to get the value of I2. Okay, so therefore the value of I2 you are going to get it as a minus 12 milliampere. Okay, so this is the direction of I2. Try to change. If you change in this direction, actually current will be flowing in this direction. So this is nothing but V1. Okay, just a small modification. So I2 is equal to V by R, and this current is flowing in this direction, and already the voltage at this point we determine it as 6 minus 30 divided by 2000 ohm, then it is nothing but 6 minus 30. When you do it with a calculator, then you are going to get as 12 milliamperes. Okay, so now let's try to substitute all this in an tabular column, then you can understand better. Okay, so the tabular column we are going to draw like this. So for this both individual I would like to draw where you will get an clarity. Okay, so the tabular column for this you are going to get like this. So here what we are making 0 is, first one we are making as I2 equal to 0. So this is a tabular column for output port is open circuited. Output port is open circuited, and here the first row you will be getting as theoretical calculations, and second row you are going to get it as practical calculation. And what are the parameters we have been find here is, see here, first one we have to find out V1, already it is known. So here we are going to write down V1. Okay, so V1 values you have to write down. So after finding V1, what are the values we have been find is, next value is V2, and next value is only I1. So already how much we are applying is 30 we are applying, and the value of V2 we obtained is how much? 11 volts, and the value of I1 we obtained is 23 milliamperes. So the same experiment you have to do the practical calculation, and you, while you do this, see that you apply 30 volts, and by using a voltmeter you have to get 11 volts, and the current using an ammeter you have to get 23. If you will be getting the similar values here, then you can confirm your experiment is correct. So you will do in the practical, then you will get an clarity. And coming to the next section here, so here also you are going to get a tabular column indicating all the parameters. So this is of theoretical values, and this is of practical values. Here you can see here what we are making 0 is I1 is equal to 0. What is meaning of I1 is 0 means input port is open circuited. So input port is open circuited. So what are the parameters we are applying is I1 is 0. So first we will be getting V2. Okay, so since V1 is 0, you have to write down. So V2 value you have to write down, and next value we have to find out is V1. Okay, and next value we need to find out is I2 value. So V2 how much we are applying, Okay, you can see here what is the value of V2 we are applying is 30 volts. What is the value of V1 we obtained is 6 volts, and we had taken the current in this direction. Okay, if you have any doubt in this, just you can check it like this. So here you are going to have 510, and here you are going to have 30 volts, and here you are going to have 2000. So previously I was taking the current in reverse. Now the original current direction I am taking, which is V2, and what is the voltage at this point is nothing but 6 volts. Therefore I2 I can write down as current is leaving. What is the leaving polarity of the voltage? 6 volts minus 30 volts divided by R. What is the R value is 2000 ohm. Therefore you will be getting it as minus 12. So this is current is minus 12 milliampere, but when this current is flowing in this direction, this will be 12 milliampere. Therefore that current I am writing, which is nothing but 12 milliamperes. So like this you are going to get the tabular columns for all the values. Then you can substitute all this in this parameter, and you can find out Z11, Z12, Z21 as well as Z22. Okay, so when you substitute here all this in this parameter, you will get it a value. So therefore the values you are going to get it as Z12 as well as Z22. So Z12 is equal to V1. Okay, so what is the value of V1 by I2, and this value is V2 by I2. The value of V1 is how much? Okay, value of V1 is 6 divided by I2 is how much? 12 milliamperes. So the value of V2 is how much? V2 what we are applied is 30 volts divided by I2 is 12 milliamperes. Then when you solve it, then you are going to get the value of this is 0.5 kilo ohms, and this we are going to get it as 2.5 kilo ohm. Okay, so we can compare these values and these values here. Okay, you will be getting approximately same. 0.5 is nothing but approximately 500 ohm. So this is a 2.5 kilo ohm, which is nothing but 2500 ohm. So this is by direct, this is direct method, and this is shortcut method or indirect method. You do by direct or indirect, the answer remains same. Hope you are able to understand. If you feel the content is useful, please give a like to the video and share with your friends, those who need this practical calculation, and kindly subscribe to my channel with the name KV Tulasiram. Thank you for your help and support. We will meet in the another video.